Welcome to English for Professional Mechanical Engineers. My name is Huang Dong-Yong. I'm going to introduce programming microcontrollers in C to you in this video clip. I'll begin with the outlines of this unit. Programs written for a microcontroller have a fairly repeatable format. Slight variations exist, but many follow the same format. Hence, let's have the anatomy of a program. Generally, program consists of the following parts. Commands include files, functions, program constants, and variables. You may notice there is one more subsection, interrupt handler definitions. The reason I put in light color is that it's less used compared to other items in this section, and I'm not going to explain it in this video clip. Yet, you had better know that when you need to deal with some unexpected occasions like emergency situation, you will need to use interrupts. After introducing the anatomy of a program, I'll talk about fundamentals of programming, which consists of operators, programming constructs, and decision processing, and references. I'll start with commands in anatomy of a program. Because I intend to use this video clip as a supplement to Introduction to Arduino, so the usage of Arduino programming is started. Commands start with 2 slashes for Arduino command in standard C. It's different. Command C start with /* combination and ends with */ combination. Commands containing program information as follows: file name, author, revision history, or a listing of the key changes made to the program, and compiler setting information, hardware connecting to microcontroller pins description, and program description. I'd like to emphasize the importance of commands. If you don't make commands within the program, it will be hard for anyone to understand how the program works, even for yourself after some time. The next subsection is include files. Most compilers require a personality file and the specific microcontroller that you are using. This file provides the name of each register used within the microcontroller. It also provides the link between a specific register's name within software and the actual register location within hardware. These files are typically called header files, and their name ends with a .h. You might need to include other header files in your program, such as the maths.h file when programming with advanced maths functions. To include header file within a program, the following syntax is used. / includes files, # include, > file name 1.h, > # include, > file name 2.h, > Here is an example for include the maths.h file. The next subsection I'll talk about is functions. It is advised to take the top-down design, bottom-up implementation approach to designing microcontroller-based systems. Now I'm going to explain the top-down approach via partition. First, the system is partitioned into subsystems, and wherever possible, a subsystem is further divided into even smaller subsystems. Eventually, you end up with doable pieces, each with a defined action. Each doable piece in computer program is called a function or a subroutine. A function is a block of statements that performs a specific task. The smallest doable piece, function in the button, is easy to write, debug, and test it. Now, I'm going to describe the button-up part mentioned earlier. The tested and proven smallest doable pieces will be used as building blocks. In contrast to the previous top-down approach, we integrate subsystems together to make a higher hierarchy subsystem in reverse order until the program is completed. Please note that a higher hierarchy function can be composed of lower hierarchy functions. I'd like to use this slide to show the hierarchy of a main program and the required functions. In this example, the main program calls two functions, function 1 and function 2. There's no need to pass any argument to or from function 1, so void is placed in the argument positions. In the other way, an input argument var should be placed from main to function 2. Again, function 1 calls an even lower hierarchy function named function 1 underscore 1 without any argument. Now let's move on to program constants and variables. The +sign define statement is used to associate a constant name with a numerical value in a program. It can be used to define common constants such as pi. It may also be used to give each specific term used in the program a numerical value. This makes the code easy to read. For example, it will be easy to read a program with decision processing by defining the value of true and false, and status of a switch by defining the value of on and off. There are two types of variables used within a program: global variables and local variables. A global variable is a variable and accessible to all portions of the program, including the function code, whereas a local variable is only known and accessible within the function where it is declared. When declaring a variable in C, the number of bits used to store the operator is also specified. The table in the right-hand side shows the byte size and range of different types of variables. Here I give you an example of declaring all the types of variables. For example, variable 1 is declared as an unsigned integer. It takes 2 bytes to store variable 1. Since 1 byte equals 8 bits, it is equivalent to say it takes 16 bits to store variable 1. After finishing programming constants and variables, I'll start to talk about fundamentals of programming. In addition to the subsection listed here, I'll give you some rules in the following slide. A statement always ends with a semicolon. As shown in this example, the statement inside the brackets, including variable declaration, function calling, and operation, all ends with a semicolon. You might wonder about what variable 2++ means in the previous example. It's an operation I introduced in the subsection operators. First, I show you the symbol, precedence, and discretion of various operators, including general operators, arithmetic operators, logical operators. You are familiar with arithmetic operation, so you know the precedence or priority of multiplication and division is higher than addition and subtraction. In the arithmetic operator table, the precedence of multiplication and division is 3, and the precedence of addition and subtraction is 4. Also, you know that parentheses has the highest priority, so its precedence is 1, as shown in the general operator table. Now you should be able to tell that the precedence 1 means the first priority, and 3 means the third priority. In addition to the operator just shown, there are bit manipulation operators and unary operators. The description in unary operators explains the function of double plus as increment. So, variable 2 double plus is equivalent to variable 2 equal variable 2 plus 1. Limited to time constraint, I'm not going to explain everything here. We have to move on to the next subsection, programming constructs. There are the for and the while looping constructs. Here I show you 2 examples using the for loop. The for loop in the first example is executed 10 times. The for loop begins with the variable loop CTR equal to 0. The decision condition loop CTR less than 10 is checked to determine whether the loop should be executed and the value of loop CTR be increased then. The loops continue until the decision condition is no longer true. The for loop in the second example is also executed 10 times, but the variable loop CTR is initialized as 10 and decreased by 1 every time in this example. And I'll show you another example to execute the loop 10 times, but the while loop is used instead. The variable loop CTR is initialized ahead of the while loop. Every time before executing the loop, the less than criterion is checked first, and the variable loop CTR is incremented inside the loop, so the loop will be executed 10 times. Frequently, in a microcontroller application, the processor executes a loop continuously. In this case, the while looping construct is the very choice. By setting the decision condition to 1, the loop will be executed repeatedly. Though we have mentioned about decision making in a loop, we haven't really talked about decision processing syntax in programming yet. This is the next subsection. On some occasions, it is necessary to make decisions. Here I list 4 decision-making constructs: the if statement, the if-else construct, the if-else construct, and the switch statement. The if statement will execute the following statement or the following code between an open and closed bracket when the condition within the if statement is logically true. And the if-else construct will do the same thing when the condition is logically true, but it will execute the statement or code bracketed for else when the condition is not true. When there are more than 2 conditions, the if-else construct will be used, as shown here. Alternatively, you may use the switch statement. When the decision variable equals a case, the statement or code bracketed for the case will be executed. Basically, you've seen the basics of programming. You might have got some ideas about programming now. It's time to go to the references section. For your information, I give you the references list. That's all for programming microcontrollers in C. Hope you are able to do some basic programming now. Thank you for watching. Have a good time and see you